Hello, today I'm going to show you how to build a health system. And so, here's the finished product before we get into the video. So, first off, the way this works is we have a very modular component-driven system. That means that if you want to apply health, it is simply a drag and drop operation. You don't need to build any complicated systems per actor. And that allows your project to be very scalable and dynamic. If you later down the line decide that you wanted to implement a Wolfenstein style health system where you can have overshield that depletes over time, and you want to be able to take that per object, you could do that easily just by setting up parameters in your component, and you wouldn't need to go back into every single health system on every single actor and rewrite it per object. So the way that I have the implementation set up here is I have this component that is currently on this cube. The cube has 40 health and my projectiles do 20 damage. So when I shoot this cube 2 times, it will die. Let's show that working. And it's gone. Easy, simple, pretty much drag and drop. Hello friends, today I'm going to show you all how to make a health system and why you'd want to make it the way that I'm going to show you. So for starters, here's how I usually see people making their health system. They'll just set up a float inside their actor class that just deals damage based off of the event any damage system that is, just set up in every single blueprint actor that exists, and then you'll print out something that just says you've been hurt. Great, this works. It's operable, but it's not necessarily efficient code, because in every single thing that I need to take damage, I'll have to copy the system. And if we start getting complicated advanced systems that might need to change as the game develops, you'd have to go to every single instance where this health is set up and then modify it in every single instance, which is not great. But hey, it works. You can see, hey, I'm getting hurt. It's operable, right? But it's not efficient. It's not going to allow us to change and have our project be dynamic as it needs change. So I'm going to show you how we want to do that. So what we're going to do is actually use an actor component. And actor components, you can just simply add them, change them, modify them at will. They don't necessarily need to reference your character or whatever you're applying health to. So it's just a very modular, efficient way of going about things. So what we're going to do is call this BP_health comp. Great. Now we made it. Simple little trick, by the way. You're going to see me pressing compile button and it's going to save. I simply hit this drop down, save on compile on success only. So that means if our code compiles successfully, then yeah, just boom, we don't have to press the save button, just removes the click. So the first thing we're going to do is get a reference to our owner, and we're going to bind into the gameplay statics functions on take damage. Great. And this allows us to actually receive the on take any damage input from the owner actor. Because that is just part of the base C++ class that Epic has provided. This event just exists on any single actor, which is very handy. So we're going to do create event. And this is just allowing us to bind into the function call or event call. I very much so like using functions. So that is what we've done. We've bound into the function here, and it created a function matching that parameter because 425 is a lovely engine version, and it lets us do that instead of having to manually make this function. So I don't like the auto-generated name, so we're going to go ahead and change that, and we're just going to go ahead and call this on take any damage. Great. So to quickly break down the parts of a function, this is the initial function call, and these variables are what you would call function parameters. We're going to use these a fair amount. So first things first is we need to create the variables that we're going to use for this function. So first off, we want to have our health. We're going to change this to a float type variable, and then we're going to create another variable. We're going to call this max health, and because the last float variable is a float, it automatically created it as another float. And we want to give some default values to these, so we're going to go ahead and set this as 100. And then, so we don't have to worry about manually setting the max health in every single instance as well, we're going to go ahead and set this on begin play equal to the current health. And the keyboard shortcuts to just drag it out like these particular nodes. I control dragged out the health, and that got the get reference, and alt dragging out got the set reference. Very nice and handy. Whoa. Perfect. Great. Cool. So now we have our untake any damage function. And what we're going to do is, first off, we want to make sure that we're able to apply damage. So I'm going to drop in this is dead boolean. We're going to use this to make sure that we're already dead and whatnot. And we also want to make sure that we're actually dealing damage. So I'm going to go ahead and do get damage. And this is just a copy of what is on the function parameters list there. So we want to make sure our damage is a valid number. We're going to make sure this is greater than 0. Perfect. We don't want to be able to apply negative damage unless we were setting up a healing system, which a little bit beyond the scope of this tutorial, so I'm not going to get into that. We also want to add in an and we're going to make sure that dead is not equal to true. We want to make sure that we are particularly not dead. That's important. And the and just means that both of these operations have to be true. We both must have damage that is greater than 0, and we also must not be dead. And just very quickly, go ahead and bunch these up together, and then add in a little comment. Shortcut for this is C, and we're just going to say valid conditions for applying damage. And this is just important, occasionally commenting code blocks so you understand what's going on. You don't necessarily need to comment every single node. Just say what basic operation they're doing, and then you can read the rest. Great. And so once we said we can actually validly apply damage, we want to get about doing that. So here's what we're going to do. We're going to set this up. And we're going to go ahead and drop in a clamp, because we want to make sure that we're staying within a defined range. Great, so we also want our health in this instance. So we're going to do health, float minus float, so minus damage. Plug that in there. And then I like setting up max health as the max. Really technically you could just set up health there. This just defines the range of values we can put in through here. We're going to set the min equal to 0, and then this will allow us to no, thank you, grab in the variable reference, to true, straighten the line. Great. Great, cool. So this should allow us to actually apply the damage. Now the next thing we want to do is make sure that our health, if we go below the number that we want to make sure that we're actually dead. So we'll go ahead and say less than 0. The reason why I use less than or equal to, considering that we just put in our minimum value as 0, is because this thing called floating point values. You can never exactly be sure that if you set a float to be 1, that it'll always be 1. Sometimes floats are just tricky and they hate you like that. So I don't give it the option to mess with me. Great. So if our health is less than or equal to 0, we're going to go ahead and call this death function, and we'll just go ahead and set is dead to be true. And then first thing that we're going to do is a little bit more complicated. We're going to create an event dispatcher. Another keyword for this, if you're using something like Unity, would be a delegate. In fact, you can see variable type over here, multicast delegate. And I can get into exactly what those words mean in a future video. Just understand that when a delegate gets called, any functions that are bound to it will also get called, which is very lovely. And Unreal also has event implementations, which is functionally the same thing at the end of the day. And we're just going to go ahead and call this on death. Lovely. And we'll call this from here. So on death will get called. Great. And from our, this is our begin play. We care about this. Awesome. And then we'll just simply call our death function. And this is lovely. One more thing that I would really like to do here is we're going to add in a little bit of debugging. So I'm just going to throw in a sequence pin so we don't have to completely offset the flow of logic here. Put this in. And I'll show you a way that I really like to debug. So we're just going to go ahead and do a print text and plug this in, and then use a format text. And you'll see why I'm doing this in a second, because this is a very handy and lovely way of going about things. So the very handy thing that we can do with formatting text is we can punch in wildcard variables and set up formatting and everything exactly the way we want to see this printed out. So we'll go ahead and do owner has taken damage. We'll say damage amount equals, actually we'll just do colon here, and we'll say damage. Great. And anything that is encapsulated inside the curly braces comes out as a wildcard pin, and this is lovely. So we'll type get owner, and we're going to print out the name of the person or object who has taken damage. Get display name. Awesome. And then we can plug this straight into the wildcard pin for the owner, and this understands it's a string and it converts that pin type to a string. And then we'll go ahead and get our damage variable, and we'll plug this directly into damage. And now whenever this gets called, whenever we take damage, boom, we print off this string and everything happens. It's great. It's lovely. And now we're going to switch back over to our first person character, and I'm going to delete this awful code because this is awful and it's bad. And we're going to delete the health variable here as well. Great. And now the most complicated step in this tutorial, we're going to add health. Okay, it's done. And then we're going to go ahead and add in this print string. We're going to set this to 5 seconds. Set the text color to be magenta because things are very rarely magenta in games, unless maybe you're making a cyberpunk game. And we're just going to say this, I am dead. 2020 vibes right there. Great. This calls from our onDeath event, which you can see we have conveniently placed in this event onDeath. Set this to be true, so what the flow of logic, we'll review it real quick, should be we take damage, we make sure that this is valid, we make sure that we're not dead, we make sure that the damage value is an appropriate value. Then we go through here, we set the damage values, we clamp it between the min and max, so 0 and maximum health. Our damage should be health minus damage, so if we're taking 5 damage and our health is 100, it should be 100 minus 5 equals 95. Great. And then we run through here. If our health is less than or equal to 0, then we go in through our death function, and then this sets as dead, meaning that, you know, if we go back into here, we should immediately stop functionality here anytime we take damage after that returns true. And then we call our onDeath event, which we are using right here. Great. And just for simplicity's sake, currently, when we press T, we apply damage, and that is just so we can demonstrate what is going on. And so here we're applying 20 damage. We need to set up our base health amount. Actually, no, that is currently set as 100. And we're also setting that on our event graph, default health. We're setting max health to be equal to health. Great. So go ahead and play. And now, yay, we're dead. Great. No, currently we can still move around and everything, but if we didn't want to do that, then we could simply go to a first person character, disable, if I can spell right, that'd be great, input, perfect. And I mean, it's going to be hard to really verify that this is a thing because you can't see my keyboard, but right, I am moving around. You can hear I'm pressing the W really loudly and I'm not doing anything. That's because we've disabled input. I mean, typically you might want to spawn in a new spectator pawn here and, you know, possess that instead and have a little spectator camera that you can fly around or whatever you want to do. But that is how you would set this up. And the beautiful thing about this is it's very abstract. If we want to put this in on anything else, it is very simple to do so. And as a quick demonstration, let's go ahead and do that. So we're going to go to our blueprint class. We're going to create a new actor and we're going to call this VP_cube. Perfect. Easy. And then cube. There we go. Perfect. And we need to do simulation generates hit events so we can actually, you know, receive damage. And great. Health comp. Perfect. Now we should be good. I'm going to go ahead and set this to be 40 so that we have to apply less damage when we do things. Perfect. I think that should be all we need to do, except actually we want to make sure that we are doing things when we die. So destroy actor. Right, that's the words. Destroy actor. Thank you. Self-reference is what we want. Connect pins. Thank you. Perfect. Compile and save. And let's go ahead and add this to our scene. And in order to make sure that it properly works, let's go to our first person projectile. Currently, it only cares if we are doing this. So let's go ahead and add in a sequence pin. It only cares if we're actually applying physics, and I don't really care about simulating physics on this. Destroy actor. We'll do this on the third. And then apply damage. Great. We're going to apply 20 damage. Thank you. Numbers. And then other will be the other actor, the thing that we've hit that we're going to damage. And then we'll check this on. And the reason why we wanted to do simulation generates hit events is so our projectile can react to the event hit. So when something collides with our cube, because we have simulation generates hit events checked, this means that when something collides with it, the thing that is collided with it, if it has an event hit, this will fire off. Perfect. So we're going to go ahead and do that. There we go. Boom. We destroyed it. That was very simple. All we had to do, again, we'll look through this, add component, health comp, apply the death thing, and then it automatically works. We don't have to do any of those silly little any event, any damage, and whatnot, and setting up gross health systems. And should we need to change anything about how our health operates, maybe we want things to actually potentially be able to regenerate the amount of health we have, we can simply do that code here. If we want to be able to apply health, we can do that here. You could even set up parameters if you wanted to make sure that some things can have regenerating health and some things cannot. That is incredibly easy to be able to do. So that's why we want to do this. Event-driven architecture and component-driven architecture is very lovely. Very helpful for creating abstract, modular, reusable code. All right. Hopefully this tutorial was helpful and useful. Let me know if there's anything you would like to see in the future. One topic that I would love to cover, and probably will in the future, would be setting up weapon systems, because they're complicated. And if you do them in a very modular way, kind of like the way that I have my health system set up, it is very easy to create a robust weapon set that is very modular and very reusable. But if there's anything else you would like to see, feel free to drop in the comments below, and I'll do my best to tackle any future problems you would like to see solved. All right, have a good day. Bye-bye.